This video is an overview of how to use images in IRSA Viewer and other tools that look like this. There are a lot of really sophisticated image analysis tools in IRSA Viewer, so this is just going to briefly go over the surface of some of these tools. This is one context in which you might encounter images in IRSA Viewer. Here I've got images loaded with the catalog overlaid. The catalog is down here and the plot is here. The first thing I want to highlight is it's overlaid the catalog, but it doesn't really look like it's overlaid the catalog because you've got these representations, these diamonds with numbers in them. It doesn't look much like a catalog, at least until you zoom in. When you zoom in enough, it does eventually show you the individual sources, but when you zoom out, it shows them binned up. It is adapting what it's showing you to try to make it possible for you and your browser to understand what's going on when there are a lot of sources loaded in. If you want to just leave it as the default, you can zoom in and have the browser decide when it shows you all of the sources in the cell and when it doesn't. But if you go to the layers option, you can control that. You can control whether the cells are large or small. You can control what the group threshold is for those cells, and you can control how it shows it to you. You can ask it for ellipses or boxes. The HealPix grid is the default. You can also have it as a heat map, and you can change the stretch that it's using and also the opacity of the heat map. If you click on the color, you can change the opacity to let you see the image, at least to some extent, through the color. I tend to like one of the other choices just because it makes it more obvious what's going on. In any case, if you zoom in, eventually it will show you all of the sources. Since this is a video that's focusing on the images, let's go to a session that just has images. Here we have 4 WISE images. For most of these tools, the color and stretch comes up locked together so that if I change the color table for one, it changes for all. If I change the color stretch for one, it changes for all. If you want to change them individually, you can unhook them. And that way you change just the currently selected one. You see the outline there? If I click on an image, then that one becomes the selected one, and you can change them individually. I'm going to lock them again, and I'm going to actually go back and put everything back to the defaults. In some of these tools, the images come up locked together by position. In this one, it doesn't, because this tool is flexible enough that it can't assume that all the images that it has loaded are of the same patch of sky. But in order to lock them together, click the image that you want everything locked to, and then go up here. It's supposed to be like a chain link. Then you can align once or align and lock. I'm going to lock by WCS, World Coordinate System. Then everything is locked, and then if I zoom in one, I zoom all together. Here I'm zooming using the mouse, but you can also zoom using these icons here. Now you may notice far lower left of the image, you can see that as I move my mouse, the coordinates are updating. If I pause, then the value under my cursor is updated. If you want to see that more easily, you click on this icon, it brings up a pop-up. Then it shows you a blow-up where you can see more precisely where your mouse is, and you can see where in the image you're looking. You can also see the readouts in several different units. Here we've got pixel size, J2000, image pixel, and value. But you can change that. It may be that instead of J2000 and image pixel, you would like J2000 decimal in addition to the sexagesimal there. I'm going to show you this too. Click lock on means that the dynamic updating doesn't happen, but I can click and then it will statically remember that even if I'm moving my mouse. See these little clipboards? If I click on it, then it copies that position to my clipboard, so then I can paste it into my notes or a spreadsheet or Python code. Here you can change that format. Right now it's copying the readout values verbatim as it appears on the screen. I can change this to be in a format that Python is expecting. So if I need to paste it into my code, then it's ready to go in the right format. Let me close that, put it back to dynamic updates, and close that. You can add many layers to these images. I can add a compass rose, coordinates. I can measure distances. So I can measure the distance between two things. Right now, it's in arc seconds, but if I go to the layers icon, it shows me all the layers that I have. These are turned off because they're wise images. It comes along all of these instrumental artifacts I can turn on or off. This is the compass rose. This is the grid. There's the distance tool. I can change it to degrees, arc minutes, arc seconds. I can also have it calculate the offset if that's what I need. I can also change the color. Here I only have 4 images loaded. Let's go to a situation where I've got many images loaded. Here I've tried to load many different images and some failed. If I go here, I get a list of all the images that I have loaded, and with one button I can delete all the failed images. But wait, since this is a table just like any other table in this tool, if I click this, it sorts by wavelength, and it sorts the images that I have loaded also by wavelength. There are a lot of images here with many different resolutions. Let's go lock by WCS, and then everything is aligned and locked. They're kind of small in this view. If I toggle this, then I get a larger view and I can scroll. There's one sort of hidden gotcha. I'm scrolling using the mouse right now. There is a scroll bar over far on the right, but if my mouse happens to be in the selected image, I will zoom rather than scroll. So let's make it fit again, and then put my mouse outside of that selected image, and then I can scroll. Now this region of the sky has a lot of really great texture in the talons of the eagle in this Eagle Nebula. I can do a lot of really nice extractions here. If I go here, I can click on this extraction tool here. The drill pokes through a fits cube. I don't have any cubes loaded right now, so I can't select that. But I can extract a line from the image. I can also extract points from the image. So if I click on this, I can draw a line across the talons and then pin that chart. So then if I shift click on the next image, I can pin that same RA index from the next image. Shift click, pin that chart. So what I'm doing is I'm extracting a line across each one of these images. At the same RA index, it's extracting the flux along that image. So it's the same RA index, and these are the pixel values on that image. I can affect exactly how it's doing that extraction because it's doing 1 pixel by 1 pixel at the moment. If I go to some of these where they have smaller pixels, then it makes more sense. Where I was an IRSA image, but I can change number of pixels over which it's averaging to do this line extraction. It also can do points extraction where you click to do individual point extractions on the image. I also can do the following. Let's make these images a little bit bigger. If I do this and do a rectangular selection, if I do this, let me make this a little bit big. If I click on the sigma, then it's calculating some statistics for us out of that box. The mean is this, the standard deviation is this, the integrated flux is this. Now when I move my mouse through this table, it's going to show me where in this box the minimum flux is, the maximum flux is, the aperture centroid is, and the flux weighted centroid is. You can also, using this selection tool, crop the image, filter down any catalog overlays, zoom in. You can also initiate additional actions. You can do additional catalog searches. You can launch a search at Ned or Simbad. You can do additional image searches. You can launch a search at Sophia or WISE for this region of sky. Now I sort of blew past this. There's searching fits and searching HIPS images. Fits images are pretty common. That's what everything I have loaded so far is here. But HIPS images are a new beast. HIPS images are designed to be dynamically adapted resolution. So the HIPS image that I have loaded here, it's been created from WISE images, and you can see the background matching is not awesome. But try to ignore the background matching and just look at what the resolution does as I zoom in. Boom. It's loading resolution on demand. It's adapting what it loads based on what it needs for the zoom level that I have. That's the power of it. It's doing adaptive resolution because it is a map of the whole sky, but it's not loading everything to the highest resolution when I'm zoomed out this far. So this kind of data format is really useful when you need to assess where things are over the whole sky on a large scale. That's the power of HIPS images. You have some of the same tools up here, and sometimes they do the same thing. But, for example, you can't really change the stretch in a HIPS image. The stretch is set by the person who created the HIPS image in the first place. You have some limited control over the color table, but you don't have a lot of control like over the background matching in this particular HIPS image. But you see HIPS images in many different places in IRSA tools. For example, this is from the Data Collection Explorer, and this is the beginning of a data collection search. You can see the HIPS image in the background there. All those little yellow footprints, those little yellow footprints are called a MOC, a multi-order coverage map. And what that is telling you where there are data. The data set that's being shown is the 2-mass large galaxy atlas, and all those little yellow footprints is where there are data from the 2-mass large galaxy atlas. So in this context, you can click and drag and zoom in on various parts of this image and then decide where you want to search. You can click in this interface and then launch a search from this interface based on what footprints you see here. You can also see this in many other tools here at IPAC. Another place that you often see HIPS images here in our tools is in coverage images. Many of our tools present a coverage image as part of our search results. That is really super useful in many different contexts because it gives you a sense of the bigger picture. Here's the results from a Sophia archive search, and all those multicolored polygons are showing you all of the individual frames that it found for the data search that I did. I was trying to search on the Orion Nebula, and all those different polygons are all the different observations that it found. Some images, some spectra, many, many different pointings. But all of those different pointings are rendered in this coverage image to help me understand the nature of the data that I found. Euclid searches also give you a coverage map. So you can see, oh, the position that I picked can be found in 3 different Euclid tiles, and the catalog search that I did covers up here, and then the second catalog search that I did covered down here. So the coverage map is really useful for figuring out where on the sky you are, especially if you're getting results that don't make a lot of sense. You don't understand exactly where you searched or what the results are, you aren't making sense. The coverage map is often really useful for figuring out, wait a minute, where am I again? Where are these observations? Super useful. Remember too that all of these tools have online help, and they often have sections specifically on images, or at the very least specifically on the visualization tools. All of these tools have context-sensitive help too, so if you see a question mark with a circle in it, you can click on that and get help relating to whatever it is that you're looking at right then.